The Hello World module. Many programming books begin with a Hello World example as a way of showing the simplest possible program. This book deals in kernel modules rather than programs, so for the impatient reader, the following code is a complete Hello World module. So first we're going to include the init.h and module.h libraries. Down here is the Hello World, and then over here is Goodbye Cruel World. So hello init and hello exit, and there they are called there. So this module defines two functions, one to be invoked when the module is loaded into the kernel, hello init, and one for when the module is removed, hello exit. So the module init and module exit lines are or use special kernel macros to indicate the role of these two functions. Another special macro, module license, is used to tell the kernel that this module bears a free license. Without such a declaration, the kernel complains when the module is loaded. The printk function is defined in the Linux kernel and made available to modules. It behaves similarly to the standard C library function printf. The kernel needs its own printing function because it runs by itself, without the help of the C library. Sometimes I like to do these checks for understanding after reading. In this case, we just read why the kernel needs its own printing function. The module can call printk because after ensmod has loaded it, the module is linked to the kernel and can access the kernel's public symbols, functions, and variables as detailed in the next section. So our next question is, after the module is linked to the kernel, what can it access? The string kern alert is the priority of the message. And we have an asterisk here. Let's go see what that means. The priority is just a string such as 1, which is prepended to the printk format string. Note the lack of a comma after kernel alert. Adding a comma there is a common and annoying typo, which fortunately is caught by the compiler. So maybe here we can ask, what is the priority? So the string kernel alert is a priority of the message. We've specified a high priority in this module because a message with the default priority might not show up anywhere useful, depending on the kernel version you are running, the version of klogd daemon, and your configuration. You can ignore this issue for now. We explain it in chapter 4. So the question is, why are we giving it a priority of 1 here? And that's the answer. And it's interesting to me that it depends on one of three things, or all three things. That is the kernel version, the version of klogd daemon, and your configuration. Maybe that implies the distro's configuration if you're using a vendor's kernel. Well, you can test the module with the ensmod and rmmod utilities as shown below. Note that only the super user can load and unload a module. So make, entering directory, usr src, here's the hello.o, building module stage 2, mod post, hello mod.o, hello.ko, and then make tells us it's leaving that directory. So then as a root user, you can type ensmod and your compiled module there. Output is hello world. And then you can remove the module and it will say goodbye cruel world. That's cool. Please note once again that for the above sequence of commands to work, you must have a properly configured and built kernel tree in a place where the makefile is able to find it. This path in the example shown is where their makefile was able to find it. We get into the details of how modules are built in the section compiling and loading. According to the mechanism your system uses to deliver the message lines, your output may be different. In particular, the previous screen dump was taken from a text console. If you're running ensmod and rmmod from a terminal emulator running under the Windows system, you won't see anything on your screen. The message goes to one of the system log files, such as varlog messages. The name of the actual file varies between Linux distributions. The mechanism used to deliver kernel messages is described in chapter 4. As you can see, writing a module is not as difficult as you might expect, at least as long as the module is not required to do anything worthwhile. The hard part is understanding your device and how to maximize performance. We go deeper into modularization throughout this chapter and leave device-specific issues for later chapters. Cool, so in the next video, I'll go over kernel modules versus applications.